Okay, hi everyone, welcome back to this live stream for Windows Server 2003. So I'll just share my screen here. Okay, in exercise 4.2, you assigned the server request security policy so that it would always be used. In exercise 4.3, we'll tweak it some. By default, all IPsec policies you create will be transport mode as opposed to tunnel mode policies. This is also true of the default local computer and domain IPsec policies. In this exercise, you will modify the local computer's server request security policy setting to improve its interoperability. So exercise 4.3, customize and configuring the local computer IPsec policy and rules for transport mode. So 1, click start, type MMC, click OK, an empty MMC console window appears. 2, select the file add remove snapping command. When the add remove snapping dialog box appears, click the add button. 3, in the add standalone snap-in dialog box, scroll through the snap-in list until you see the one marked IP security policy management. Select it and click the add button. The select computer dialog box appears. Select the local computer radio button and then click the finish button. 5, click the close button in the add standalone snap-in dialog box and then click the OK button in the add remove snap-in dialog box. 6, select the IP security policies on local computer node in the MMC. In the right hand pane of the MMC, right click the server request security policy and choose the properties command. The server request security properties dialog box appears. 7, select all IP traffic rule and then click the edit button. The edit rule properties dialog box appears. 8, switch to the filter action tab, select the request security optional filter action and then click the edit button. The filter actions property dialog box appears. 9, click the add button. When the new security method dialog box appears, click the custom radio button and then click the settings button. 10, in the custom security method settings dialog box, check the data and address integrity without encryption AH checkbox, and in the drop down list select SHA1 using the drop down lists under ESP. Set integrity to SHA1 and encryption to 3DES. 11, first check the generate a new key every checkbox and set the key generation interval to 24,000 kbytes. Kbytes must be in the range 20,480 to 147,483,647 KB. Then click the next generate a new key every checkbox and specify a key generation interval of 1,800 seconds. 12, click the OK button in the custom security method settings dialog box and then click OK in the new security method dialog box. 13, when the IP filters property dialog box appears, use the move up button to move the custom filter you just defined to the top of the list. 14, click the OK button in the IP filter properties dialog box. 15, click the close button in the edit rule properties dialog box and then click the OK button in the server request security properties dialog box. Configuring IPsec for tunnel mode. Until now, we've primarily been discussing IPsec in transparent mode. As you read earlier, you can also use IPsec in tunnel mode. You can use IPsec tunnels to do a number of useful, interesting things. For example, you can establish a tunnel between two subnets, effectively linking them into an inter-network without needing to have a private connection between them. IPsec tunneling isn't intended as a way for clients to establish remote access VPN connections. Instead, what you'd use to connect your Windows Server 2003 network to a remote device, for instance, a Cisco PIX that doesn't support L2TP plus IPsec or the point-to-point tunneling protocol PPTP. You can also build a tunnel that directly connects two IP addresses. Either way, you establish the tunnel by building a filter that matches the source and destination IP address, just as you would for an ordinary transport mode. You can use ESP and AH on the tunnel to give you an authenticated tunnel AH only, an encrypted tunnel ESP only, or a combination of the two. You can control this behavior by specifying a filter action and security method. However, when you build a tunnel, you can't filter by port or protocol. The Windows Server 2003 IP stack doesn't support it. To construct a tunnel properly, you actually need two rules on each end, one for the inbound traffic and one for the outbound traffic. Microsoft warns against using mirroring on tunnel rules. Instead, if you want to link two networks, you need to specify settings as the ones shown in Figure 4.17. Each side's rule has two filter lists. The Atlanta filter lists specify a filter for outgoing traffic that has a Seattle router as a tunnel endpoint, and then another filter for incoming traffic from any IP subnet that points back to the Atlanta tunnel endpoint. In conjunction with these filter lists, you'd specify a filter action that provided whatever type of security was appropriate for the connection. So you can see here, Figure 4.17, filter lists for a simple tunnel. You specify whether a connection is tunneled or not on a per rule basis using the tunnel setting tab of the Edit Rule Properties dialog box. Select Server Request Security, right-click and select Properties. In the Properties dialog box, select the All IP Traffic rule and click Edit Rule Properties dialog box. Select the Tunnel Setting tab. The two radio buttons specify whether this rule establishes a tunnel or not. The default button, this rule does not specify an IPsec tunnel, is self-explanatory. To enable tunneling with this rule, select the tunnel endpoint is specified by this IP address and then fill in the IP address of the remote endpoint. Figure 4.18, the tunnel setting tab of the Edit Rule Properties dialog box. In exercise 4.4, you will configure a policy for IPsec tunnel mode. Configuring a policy for IPsec tunnel mode. This lab requires you to use two separate machines to which you have administrative access. Let's call them machine A, machine B. Before you start, you'll need their IP address and you'll need to have their local IPsec policies open in the MMC. First, configure machine A. Right-click the IP security policies on the local computer node, then choose Create IP Security Policy command. The IP Security Policy wizard appears. Click Next. 2. Name your policy tunnel to B and then click the Next button. 3. On the Requests for Secure Communication page, turn off the Active Default Response Rule checkbox and click the Next button. When the summary page for the wizard appears, make sure the Edit Properties checkbox is on and then click Finish. The Tunnel to B Properties dialog box appears. Click the Add button on the Rules tab. The Welcome to the Create IP Security Rule wizard begins. Click Next. 5. In the tunnel endpoint page of the wizard, select the tunnel endpoint is specified by the following IP address and enter the IP address of machine B. Click Next. 6. In the network type page, select local area network LAN, click next. 7. Select all IP traffic radio button, click next. 8. Select the request security option radio button on the filter action page, click next. 9. In the authentication method page, select Active Directory default Kerberos v5 protocol, click next. 10. Clear the edit properties checkbox, click finish, then click OK. Now repeat steps 1 through 10 on machine B, creating rules using the appropriate IP addresses and names, e.g. tunnel to A, the IP address to match machine A in steps 2, 5. Managing and monitoring IPsec. Now that you know how to configure IPsec, it's time to learn how to manage and monitor it. The management aspects of IPsec are pretty simple because 90% of your workload will be building filter lists, rules, and filter actions that correctly specify the traffic and hosts you want protected. The remaining 10% will be monitoring and troubleshooting the rules we have established. There are a number of ways you can monitor IPsec on your computers, but the two most useful methods are viewing the security associations and traffic flowing between specific computers in IP Security Monitor and checking the event log for IPsec related events, as you will see in the following sections. Using IP Security Monitor. In Windows Server 2003, the IP Security Monitor is implemented as an MMC snap-in. The snap-in allows you to view details about IPsec policy at either the domain or local level and provides you with a way to view main mode and quick mode statistics. In addition, you can view SAs and execute complex files. So to begin, you must install the IP Security Monitor, and MMC exercise 4.5 shows you how to add the snap-in. So adding the IP Security Monitor to the MMC. 1. Click Start, Run, type MMC and click OK. 2. Select Add Remove Snap-in on the File menu and click the Add button. 3. Select IP Security Monitor in the list of snap-ins and click the Add button. Click Close and then click OK. You should return to the MMC and the snap-in appears in the left pane. To save the MMC, select File, Save, and specify a name and location in which to save the console. The IP Security Monitor snap-in is shown in figure 4.19. The local computer appears in the IP Security Monitor snap-in by default. If you want to monitor other machines on the network, you can easily add them by right-clicking IP Security Monitor in the left pane and selecting Add Computer. If you are in a domain, you must have administrative privileges for the domain in order to add remote machines to the console window. To view details of the policy assigned to the machine you are monitoring, expand IP Security Monitor server name, active policy. The policy details are described earlier in this chapter as listed in the right pane. See figure 420. So it's figure 420, active policy details. You can also use IP Security Monitor to view IP security statistics for main mode and quick mode negotiations. To do this, click the statistics node under either main mode or quick mode. The various statistics appear in the right pane and display information such as the number of bytes sent and receive, send, receive, and negotiation or authentication failures, and much more. The main mode statistics are shown in figure 4.21. So you can see here. Okay, so table 4.1 lists the main mode statistics and what they track. Statistic description. Active Acquire the number of requests required to initiate an IKE negotiation to establish SAs between IPsec-enabled machines includes the current request and any requests waiting in line, typically 0 unless the load is particularly high. Active receive number of IKE messages waiting for processing. Acquire failures number of requests to establish SAs between IPsec peers that have failed since last IPsec restart. Receive failures number of errors that occurred during the IKE message receive process since the last IPsec restart. Send failures number of outbound IKE messages that failed since the last IPsec restart. Acquire heap size number of successful outbound requests for SAs between IPsec peers. Receive a heap size number of successful incoming IKE messages. Authentication failures number of authentication errors that have occurred since the last IPsec restart. Errors could be due to mismatched authentication methods or misconfigured authentication method configuration. Negotiation failures number of negotiation failures since the last IPsec restart. Failures could be due to mismatched authentication methods, incorrect authentication method configuration, or mismatched security methods or settings. Invalid cookies received. Number of cookies that could not be matched to an active main mode SA. Cookies are stored in received IKE messages and are used to identify the corresponding main mode SA. Total acquire. Total number of requests to establish a main mode SA since IPsec was started. Total get SPI. Total number of requests to the IPsec driver for a unique security parameters index SPI, which matches inbound packets with SAs. Key additions number of outbound quick mode SAs added to the IPsec driver. Key updates number of inbound quick mode SAs added to the IPsec driver. Get SPI failures number of failed requests to the IPsec driver for a unique SPI. Key additional failures number of failed outbound quick mode SAs added to the IPsec driver. Key update failures number of failed inbound quick mode SAs added to the IPsec driver. ISADB list size. Total number of successful main mode entries pending main mode negotiation and failed or expired main mode negotiations. Connection last size number of pending quick mode negotiations. IKE main mode. Total number of successful SAs that have been created in main mode since last IPsec restart. IKE quick mode. Total number of successful SAs that have been created in quick mode since last IPsec restart. Soft associations number of SAs created with non-IPsec enabled machines but allowed by the computer's policy to communicate. Soft associations are not IPsec secure. Invalid packets number of IKE messages with invalid header fields, incorrect payload lengths, or incorrect cookie values, usually the result of retransmitted IKE messages or mismatched pre-shared keys. Active security associations. Total number of active quick mode SAs. Offload security associations. Total number of quick active mode SAs accelerated by special hardware such as NIC, which is a network interface card that supports SA acceleration. Pending key operations. Number of IPsec key exchanges that have been queued but not completed. Key additions. Number of successful quick mode SAs added since last restart. Key deletions. Number of successful quick mode SAs deleted since last restart. Okay. Rekeys total number of rekeyed quick mode SAs since last restart, active tunnels, number of active IPsec tunnels, bad SPI packets, total number of packets affected by a bad SPI since the last restart. Usually this means that a packet is attempting to use an expired SA. This statistic could be high if rekey intervals are short and the number of SAs is greater during a packet spoofing attack. Packets not decrypted, number of packets that failed to decrypt since the last restart. This could happen if a packet fails a validation check. Packets not authenticated, number of packets whose source could not be verified by the computer. High values could indicate packet spoofing, modification attack, or corruption by network devices. Packets with replay detection, number of packets with an individual sequence number since the last restart. Confidential bytes sent, total number of bytes sent that were encrypted under ESP. Confidential bytes received, total number of bytes received that were encrypted under ESP. Authenticated bytes sent, total number of bytes sent that were authenticated under AH or ESP. Authentication bytes received, total number of bytes received that were authenticated under AH or ESP. Transport bytes sent, total number of bytes sent in transport mode since last restart. Transport bytes received, total number of bytes received in transport mode since last restart. Bytes sent in tunnels, total number of bytes sent in tunnel mode since last restart. Bytes received in tunnels, total number of bytes received in tunnel mode since last restart. Offload bytes sent, total number of bytes sent with hardware offload since last restart. Offload bytes received, total number of bytes received with hardware offload since last restart. IP Security Monitor is also useful for viewing the filters that apply to the machine that you are monitoring. Without the IP Security Monitor, it can be difficult to remember which filters apply to which machines. You can easily determine the nature of the filters on your network by clicking the generic filters and specific filters nodes under the main mode and quick mode categories. The filter appears in the right window pane along with several details such as the filter name, source destination, and so forth. The details displayed relate to the topics discussed in setting under the IPsec parameters in this chapter. Finally, IP Security Monitor displays the policies and SAs of the computer that you are monitoring. You can double-click a policy to see the AH and ESP types that are in use, as well as the key lifetimes and PFS settings for each method. The Security Associations node is useful for troubleshooting communications between two computers. You should ensure that the server's IP address is listed in the Me column and that the client's IP address is listed in the peer column. If not, the SA is invalid. So I'm going to leave it here this evening for this live stream. Thank you for spending the evening with me and have a good week. Thank you.